Okay, today we're still in chapter 5. We're doing 5.4, which is using medians and altitudes. Okay, first of all, a triangle will balance at a particular point. This point is the intersection of the medians of the triangle. Okay, a median of a triangle is a segment from a vertex to the midpoint of the opposite side. All three medians of a triangle are concurrent. The point of concurrency, called the centroid, is inside the triangle. We're going to get a picture on the next slide, but these are the vocabulary words you need to write down. A triangle will balance at a particular point. So if you had a pencil and you sort of set the triangle on top of the pencil, it would balance as long as that was where the three medians of the triangle meet, which is called the centroid. So let's look at our picture. Okay, let me fill this in real quick. Okay, theorem 5.8, concurrency of medians of a triangle. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, the medians of triangle ABC meet at point P, and AP is 2/3 of AE, BP is 2/3 of BF, and CP is 2/3 of CD. Okay, let's look at that again. The medians of ABC, okay, I drew in the medians, and we said the definition was I go from a vertex to the middle of the segment across from it. So I went from C to halfway in between AB, from vertex B to halfway in between AC, from vertex A to halfway in between BC. And mathematically, we could say that AP, this segment right here, is 2/3 of the whole segment. So I have 2/3 here and 1/3 here. Okay, this segment is 2/3 of the whole distance, and this segment is 1/3. Okay, same with this one. This one's 2/3, this one's 1/3. 2/3, 1/3. And of course, we're going to use that ratio in some algebra problems in this chapter. All right, in triangle RST, Q is the centroid, and SQ equals 8. Find QW and SW. We know that SQ is 2/3 of SW. We know that SQ is 8. I'm going to multiply both sides by the reciprocal, which is the same as dividing both sides by the fraction. Okay, those are gone. 3 times 8 is 24. Divide by 2 is 12, equals SW. So that full length is 12, which means QW is 12 minus 8, which equals 4. Sorry, QW is 4, SW is 12. Example 2. I need a graph for this one. Hold on a second. Okay, let's talk about this one. The vertices of triangle FGH are given. Which ordered pair gives the coordinates of the centroid P of triangle FGH? Okay, the coordinates of the centroid. Now remember, the centroid is where, if we drew a line from the vertice to the midpoint, vertex to midpoint, vertex to midpoint, vertex to midpoint, centroid is in the middle. Okay, so first of all, I sketched FGH. Then I'm going to use the midpoint formula to find the midpoints of each side. First, we're going to do FH. So I'm going to find the midpoint of FH. So the midpoint the midpoint of FH, is x plus x over 2. So 2 plus 6 over 2, and y plus y over 2. 5 plus 1 over 2. So my midpoint is 8 divided by 2 is 4. 6 divided by 2 is 3. So I'm going to go 1, 2, 3, 4, 1, 2, 3. My drawing is awful. Let me check some things. 2, 1, 2, 3, 4, 5. Let's see. Oh, I can't erase that. Sorry, my drawing is pretty bad. Let's try this. 1, 2, 3, 4, 1, 2, 3. Well, that's not possible. 1, 2, 3, 4, 5. There's the problem. H is supposed to be over here. And I can't erase that. So we're going to look at the bold lines. And this dot right here is the midpoint of FH. Cool. All right, the centroid, we know, is 2/3 the distance from each vertex. Okay, so if I drew a line from the vertex awful, from the vertex to this midpoint, let's label this K. So the centroid, if we call that P, from G to P is 2/3 from G to K. I said G, I wrote H, from G to K, right? The centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So let's do the distance. What is the distance of GK? I'm going to have to continue on the next page, just warning you. So the distance of GK is x minus x. G is 4, so x minus k is 4 squared plus y minus y. G is 9, k is 3 squared. Okay, next slide. So write this down because I'm moving to the next slide. 4 minus 4, 9 minus 3. So this should be a straight line. So if I count 1, 2, 3, 4, this is my centroid. P, and if G is 4, 9, P is going to be 4, 9 minus 4 is 5, which is B. Excellent work. There is one of these on your homework, so if you don't understand that, make sure you ask a question. 4 minus 4 squared, 9 minus 3. 0 squared plus 6 squared, 36. So GK is 6. Awesome. So 2/3 of 6. 2 times 6 is 12, divided by 3 is 4. Okay, so the centroid is 4 units down on GK. I'm going to go back and look at that. Forward again. All right, you try. There are 3 paths through a triangular park. Each path goes from the midpoint of one edge to the opposite corner, or vertex. The paths meet at point P. So point P is the centroid, right? I'll do this first one because there's 2 more for you. If SC equals 2,100 feet, find PS and PC. Okay, if you remember the definition, the centroid is 2/3 of the distance from the vertex to the midpoint. So the centroid is 2/3 the distance from the vertex to the midpoint. So we know that CP is 2/3 of SC. So CP equals 2/3 times 2,100. 2 times 2,100 is 4,200. Divide by 3. 3 goes into 4 one time. 3 goes into 12, 4. All right. So, sorry, I said CP. PC is 1,400 feet. And you can just do some simple subtraction. The original, like the full segment length, is 2,100 minus 1,400 means that PS is 700 feet. Okay, you try the next 2. Here we go. If BT equals 1,000, find TC and BC. Go. I'm pushing pause. Okay, T is the midpoint of BC. So BT and TC are congruent. So TC equals 1,000 and BC equals 2,000. Last one. Push and pause. This one's just a tad bit confusing, but not awful. We know that PA equals 2/3 of TA, because that's the definition of centroid. PA equals 2/3 of TA. Wrote it right here. So technically, PT equals 1/3 of TA. Okay, those are our fractions. PT equals 1/3 of TA. So I wrote that down. We know that PT equals 800. 1/3 TA. I multiplied both sides by 3 and solved for TA. Then I went back to the original equation, plugged in TA. Okay, PA equals 2/3 of TA, and I solved for PA. Okay, video break. Good job today.